Okay, here we go. We are doing lesson 1-3, which is real numbers and the number line. And I really want to record this and write as much of it on here as possible so that I can post it to the thing. So I might try sporadically. Why is it blinking? Oh, it stopped blinking. To turn this back on. But you're not going to see everything I write right now, but you're going to hear me say it, and it's sitting in front of you. And then when I need you to see something, I will write that on the board. But for now, most of this is words that we can just fill in. So that very first bullet says a number A is a blank blank of a number B if A squared equals B. Okay? The words you're going to write there, does anyone know them? Square root. Okay, so those two blanks are square and root. A number A is a square root of a number B if A squared equals B. Okay, so look at that next bullet down. It says 7 squared equals 49. So 7 is that first blank, is a square root of 49, right? That means if you multiply 7 by itself, it will become the 49, okay? What's the square root of 36? 6. What's the square root of 121? 11. 144 is the 12. Okay, so in a square root, the square root symbol, right, the little check mark with the line over top, that's called your radical symbol. The number that comes under it is called your radicand. I don't usually refer to it as the radicand. Gentlemen, stop pushing. But mathematically speaking, that's what it's called, okay? Why don't you get your calculator out for me real fast? I just want to make sure you know where this symbol is on your calculator so that you can, in fact, take a square root if needed. So this is actually a second key. See the X squared button on the left side there? Does anyone not have this calculator? The TIX30? Do you know where yours is on there? Okay. Anybody else not have this one? Yours, well, same format, right? Okay. So you're going to go second and then X squared. Notice right above it, there's this symbol. Okay, and then there's this symbol. Which one do we want? With the X or without the X? Without the X. Don't use this one. This one is if you need to take like a third root, a cube root we call it, or a fourth root. Then you put a number in for that X first. You won't do that right now. You'll. So you hit the blue button, the second key, and then the X squared. Okay. Okay. And I saw my thing wig out a little bit. So let's see if it's working. No, you want to. Maybe you don't want to. Oh, that's progress. That is
hooray!
Fantastic. Okay. So simplified version of each expression. I want you to go through A through F right now and see if you can calculate those without your calculator. See if you know them in your head. Okay? If you don't know them in your head, then use your calculator. But I want to see which ones you know without your calculator first.
What do we do about the fraction?
Ooh, you try it right now, and I will tell you in a minute.
What do you do for fraction? Oh, you find the square root for both the numbers. And you put that together. Mm-hmm. 3 and then what's the square root of 64?
Don't worry about it. If you don't know it yet, we'll get there. Just try them. Just try each one. All right, we're going to go through them. What is the square root of 81? 9. Okay, now here's the deal. Technically, you can say -9 is also, like if I took -9 times a -9, I would get a positive 81, right? This is called the principal square root. We're just focusing on the positive version of it right now, but you'll see in homework stuff and eventually they'll start to throw in positives and negatives or a positive and a negative on a problem. You keep whatever symbol is out in front, okay? So this is 9. The fraction, I heard some of you explain it. This is essentially the square root of 9 divided by the square root of 16. The square root of 9 is 3. The square root of 16 is 4. So you leave it as that fraction, 3/4. What'd you get for C? Square root of 64 is 8. The square root of 25 is 5. The square root of 1/36. 1/6. So the square root of 1 is 1. The square root of 36 is 6. So 1/6. Okay, which leaves us with F, which is what? 9/11. Square root of 81 is 9. Square root of 121 is 11. Okay. The square of an integer. So some whole number or the negative version of that whole number. That's an integer, right? Positives and negatives. Are there decimals with integers? No decimals, right? So just the whole numbers, positive and negative. The square of one of those numbers is called a perfect square. Okay, so we're just going to list the perfect squares. If it were me and I was doing homework assignments that worked a lot with perfect squares, I would do this every time. I would write down the perfect squares at the top of my homework so I don't have to even think about it. They're just there and I can refer back to them. Okay, 1 times 1 is 1. We're not going to list that one. But what is 2 times 2? 4, right? That's 2 squared. What is 3 squared? 9. That is 9. 4 squared? 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 100. 11 squared. And 12 squared. Do you know 13 squared? Good job, 169. Typically 1 through 12 is a pretty thorough covering of the perfect squares. So if I were you, I would either pull these notes up while I'm doing perfect square stuff or just rewrite them at the top of your homework when you need them or copy and paste this to the top of your homework. They come in really handy when you do something like this next problem. Sometimes they're going to ask you to estimate square roots. Okay, now there are 2 ways to do that. The first way is you estimate it without your calculator by just finding the 2 perfect squares that are closest to it, okay? Now, square root of 386 is big, so maybe you need to use your calculator. But when they're smaller numbers, I'll show you another smaller one. Actually, you know what? I'm going to do a smaller number. Just cross this out. Let's make it a smaller number. We're going to say the square root of 78. How about? Square root of 78. Okay, so if I want to know what the square root of 78 equals, maybe you want to write these in down here. This was 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, so on and so forth, right? If I'm looking for what is the square root of 78, I'm looking for what number times itself got me 78. Well, if you look up here, it's got to fall between those 2, right? 64, 78, 81. which one is it going to be closer to?
9.
The 9, right? It is closer to 81 than it is to 64. So if I was going to estimate this, I would say it's between the square root of 64 and the square root of 81. So it's between 8 and 9. But because 78 is closer to 81 than it is to 64, my best estimate is this is approximately 9. Does that make sense? So you find the two that it's closest to, and then you say, okay, of those two, which one are we actually closest to? We are closest to the square root of 81, so that would be approximately 9. Now plug it into your calculator. Plug in the square root of 78. You get 8.831760, right? It just keeps going. So I would say if we're approximating, that is about 9. So notice we get the same answer, whichever method we choose, but you should be able to do both methods for me, okay? There, I think I put a question on your quiz that said, show your work. So that means don't just plug it into the calculator. I want to see which two were you between, and give me that number, CK. I don't remember. They're usually around 25, but I don't know that I calculated it yet. Questions on that? Do you want to try one more?
Yeah.
Okay, let's try, actually, here you go. This first, or example 2. What is the value of the square root of 34 to the nearest integer, nearest whole number version of this? So the square root of 34, it's going to be between which two perfect squares? 25 and 36. Which one is it closer to? The square root of 36. And the square root of 36 is what? 6. So we would say this is approximately 6. Okay. If you plugged it into your calculator, the square root of 34, oh, they're up there fixing leaks, comes out to 5.8. Okay. To round that to the nearest integer would be 6. All right. So what would 79 be? Oh, that's what we just did.
9.
It would be closest to 9, right? It's between the square root of 64 and the square root of 81. 64, 79, 81. So that's approximately 9. Someone forgot to turn their stuff off. So closest to 9. Okay? Questions on that? Okay. I think this is what you were talking about. Who asked me this question? Did you ask, Allie, if we had to know all the different sets of numbers? No? Was that you? You asked if we have to know all the, like, the rational, the irrational. Yeah, here you go. So we're going to talk about types of numbers, okay? There are 2 main categories, but really there's one big category. Every type of number we're going to talk about is what kind of number? Real. Okay, on that test I gave you, every single one of them should have circled real, right? They're all real numbers. So here's your freebie.
How are they fake?
How are they fake? There's imaginary numbers. Those are not real numbers. I'll explain those when you get to Algebra 2. But anyway, all of them are real numbers. But then under that umbrella of real numbers, they split off into 2 categories. Does anyone know what the 2 are?
Irrational.
Yes, it's rational and irrational. So this first one, a rational number, is anything you can write as a fraction. So A over B, right, is a fraction. Anything you can write in that format is a rational number, but that means it can be a terminating decimal. What does terminating mean?
Repeating.
Not repeating. If you terminate something, you do what? End, okay? So a terminating decimal is a decimal that has an end. In other words, not pi, okay? So a decimal with an end, like 5.45 or like 2.7, okay? Those are terminating decimals. Those are rational numbers. It can also be a repeating decimal. And repeating decimals, for instance, like this, is written with a bar over top as 0.416 repeating. So that 6 keeps going. Or maybe the number 1.3 repeating. How could we say that? 1 and...
3.
What's 0.3 repeating as a fraction?
1/3.
1/3, right. So 1 and 1/3, okay? Okay, so those are rational numbers, but then under the umbrella of rational numbers. So our big umbrella right now is real numbers. And under real numbers, there's two different ones. There's the rational and then the ones we'll get to in a minute. So right now we're under this umbrella, this rational umbrella. These next 3 bullets are all rational numbers, okay? The first one is what we call the counting numbers. Those are called the natural numbers. And I always tell people to remember this by thinking, if I were naturally going to count to 10, what would I do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? The natural numbers. If I take those numbers, 1, 2, 3, but I tack a 0 on the front, do you know what those are called?
Unnatural.
No. Those are called the whole numbers. Here's how I tell people to remember this. There's a 0 in the middle of the word whole. It's not a 0, but it looks like a 0, right? An O. So the whole numbers are the natural numbers and 0. Okay, 0, 1, 2, 3, so on and so forth. So does anyone know what the positive and negative whole numbers are? -2, -1, 0, 1, 2. Those are integers. Okay, and you can see that here. They keep going in both directions. So off into the negatives, off into the positives. Notice this does not include fractions or decimals. Integers cannot have fractions or decimals. Okay. Questions on that? Okay. Then the other umbrella that falls under real numbers is irrational. And an irrational number can't be written as a fraction or a terminating decimal or a repeating decimal. Basically, it's the goofy numbers. It's the things that look like they go on forever and have no rhyme or reason to them. It's just, it's not repeating. So 0.1010010001, there's a pattern there, right? But it's not the same thing over and over. It's not a repeating decimal. Or the number pi. Okay, 3.14159 is as far as I go. 265. Does anyone have pi memorized to a certain number? I feel like there's always one kid in the class that has pi to like 27 numbers. No? Those are irrational numbers, okay? I'm just going to take you down here real fast. This kind of gives you a visual, right? So the big umbrella is real numbers, but then the reals get split into irrational and rational, and then inside of rational is integers, which has whole numbers inside of it, which has natural numbers inside of it, okay? So these are all rational, and then you work your way smaller and smaller in each category. All right, jump back up a little bit here. It says some square roots are rational numbers, and some square roots are irrational numbers. And that seems odd, but think about what it means. The square root of 4 is better written as what number? 2. That is a rational number. 2 is a rational number. So even though it doesn't look like it because you see the radical, it is, okay? The square root of 25 is 5. That is rational. But the square root of 3 is hideous. The square root of 10, also hideous. Those are not rational. Those are irrational radicals, okay? Irrational number. But they all fall under the category of real numbers. So everything is real in this class. We don't touch imaginary numbers in Algebra 1, Okay. Any questions on that? Okay, then we're gonna keep moving. So classifying, there are going to be sometimes one set of numbers that it falls into and sometimes 4 sets of numbers that these fall into. So we're gonna classify them as best we can. I'm totally gonna abbreviate. If you really wanna abbreviate, let me just show you. Real numbers is like an R with a double line. Rational, God bless you, is a Q because we can't use an R anymore because we used it for real. Integers is a Z. Whole numbers is a W. Natural numbers is an N. And then irrational gets the I. So just don't call an integer I, right? Integer is Z. Irrational is I. So if you want to do that, you're welcome to do that. If you want to just write the word, you can write the word. I'm going to write the word right now just so I don't confuse anyone who doesn't want the symbol, the abbreviated version. All right, so the number 15. And by the way, everything's real, right? You know what? You don't have to write real because the question asks to which subset of the real numbers. So real is implied on this one, okay? So it is real. Is it rational or irrational? Rational. It is rational. Okay. Is it an integer?
No.
15. It is. Remember, the integers are the counting numbers and 0 and negative. So all of these are integers, right? Including a number like 7 or 15 is an integer. So this is an integer. Is it a whole number? Yes, this is a whole number. Is it a natural number? Yes. Okay, so here's the deal. You might want to swap how you write these because if something starts as a natural number, it will be every other set, right? Naturals are whole numbers, integers, and rational. So you might want to start at the innermost and work your way to the outermost. It's not a terrible idea. Letter B, negative 1.4583. What is that? What? It's not irrational. It's not an integer. It's rational because it's a terminating decimal. But remember, integers don't have decimals, okay? So this is just a rational number. How about the square root of 57? Did you plug it into your calculator? Is that a perfect square? No, it is irrational. It is a decimal that just keeps going with no rhyme or reason. That's irrational. What about letter D, the square root of 9? That is a natural number, right? Because the square root of 9 equals 3. So if it's natural, it is also whole, it's also an integer, and it's also rational. What about 3/10? It's rational. It can be written as a fraction. It is rational. Okay. I'm going to let you try those other ones on your own later if you want. I always will put more examples than we necessarily need. But if we have time, I'll go to some of those, okay? We're not going to do those ones right now because I want to make sure we're going to get through the rest of this. Next point, an inequality is a math sentence that compares the values of two expressions using an inequality symbol. The less than symbol points to the left if you think of it as an arrow, right? Less than goes left. The greater than symbol goes to the right. What do you do when it's less than or equal to? Good job. Less than or equal to. Put the bar underneath, okay? Greater than or equal to, put the bar underneath. Okay, so we want to compare using those symbols, these numbers. The square root of 12 and 4 1/3. Now you might not know what those equal, but your calculator does, right? If you plug in the square root of 12, what do you get? Just give me like 2 decimal places. 3.46, okay, is the square root of 12. What's 4 1/3 as a decimal? 4.3 repeating, right? If you don't know that, just type in 1 divided by 3, okay? Which way does your symbol open? It's going to open toward the 4 1/3. It's the less than symbol, right? 4.3 is bigger than 3.4. Okay, so we're comparing those numbers. What does pi equal? Give me 2 decimal places. 3.14, okay? Compared to 3.2 repeating, which one's bigger? 3.2 repeating, right? A 2 is bigger than a 1. So that's a greater than for that one. Okay, so the last thing we're going to do is put these in order then. Here's what you need to do with this. You need to know what they equal as a decimal so we can compare all the decimals. So the square root of 4 is 2. This is going to be 0.4. This is a negative 0. Anybody? 6 repeating. 0.6 repeating. If you don't know that, you plug into your calculator 2 divided by 3. Right? A fraction is a division problem. The square root of 2. 1.41. And then a negative 1.5. Now here's the thing. You have decimals. I want your answer to be the numbers I gave you. So these need to be your answers. But what would the smallest one be? What's your least? Negative 1.5. And here's what I would do if I were you. After you've used it, cross it out so that you don't get it mixed up, okay? What's the next smallest? Negative 2/3. And don't use negative 0.6. Use the one I gave you. So negative 2/3. Okay, so the negatives are done. What's the next smallest? 0.4. Okay, then what? The square root of 2 is 1.41. So your last answer, don't write it as 2. It's the square root of 4. So from least to greatest, you get that. Oh, impeccable time.